the next session of strength of materials. I am solving question 10 for SF and BM. Draw SFD and BMD for the beams loaded as shown in the figure, giving all the important points. A, B, C, D and E are the important points. So I'll start drawing the FBD. This is my point A. It is hinged over here. So I will draw only VA. At point B, there is a force in downward direction. This is C. Here I'll have 2 into 2, 4 kilonewton at a distance of 1 meter from each end. At point D, you can observe there is a roller support. So this will be VD. And here again it is 2 kilonewton over a distance of 1 meter. So it will be 2 kilonewton. And the distance will be 0.5 meter. This is my point E. Now this is my FBD. I'll calculate the value of VA and VD first. I'll start with summation of force in y direction is equal to 0. Upward forces are positive. VA is moving upwards, minus 5 kilonewton. I have minus 4 minus 2 plus VD is equal to 0. So I'll have VA plus VD equal to 11. This is my equation 1. Next I'll use summation of moment about A is equal to 0. Clockwise moments are positive. So first I'll have 5 turning clockwise. So I'll have 5 into 1. 4 turning clockwise. So plus 4 into 3. I have VD going anti-clockwise. So minus VD into 4. And I'll have 2 turning clockwise. So plus 2 into 4.5. I get the value of VD as 6.5 kilonewton. When I substitute the value of VD in this equation, I get the value of VA as 4.5 kilonewton. To the left of section, if I see any force going upward, I'll say it is positive shear force. I'll start with point A. VA is 4.5 kilonewton and VD is 6.5 kilonewton. So to the left of A, I'll get the value as 0. Shear force to the right of A. For that I'll have to stand to the right of A. I can see VA very clearly, so I'll get the value as 4.5 kilonewton. Next I'll stand at B and I look to the left. I get the same value that I got here. So I'll write down it is equal to shear force to the left of B. For shear force to the right of B, I'll move a little ahead of B. So 5 kilonewton downwards also becomes visible. So I have 4.5 minus 5 is minus 0.5 kilonewton, which will be equal to the shear force at C, because when I stand at C, I'll see the same thing which I saw by standing to the right of B. Next I'll go to the point D. When I stand at D and I look to the left, I'll see VA minus 5 and minus 4. So shear force to the left of D is 4.5 minus 5 minus 4, which will be minus 4.5 kilonewton. Now when I stand to the right of D, this force going upward becomes visible apart from these forces. So I get shear force to the right of D is equal to 4.5 minus 5 minus 4 plus 6.5. So I get the answer as 2 kilonewton. Last I'll calculate the shear force at E. When I stand at E, all the forces become visible. So shear force at E is 4.5 minus 5 minus 4 plus 6.5 minus 2. I get the answer as 0. Here it was 2. I added minus 2, so it became 0. So it starts at 0, ends at 0. My calculations are correct. Now I'll plot the SF diagram. I have a mix of positive and negative values. So I'll draw the graph somewhere at the center. My SFD values will be in kilonewton. This is A, Then I have B, C, D and E. Left of A, the value is 0. Right of A, the value is 4.5, which is the highest positive value. I have the same value at left of B, so this is 4.5. Right of B, the value is minus 0.5, which is the same value at C. Left of D has value minus 4.5. Right of D has 2 as a value, and at E I get the value as 0. Now I'll join these points. I'll start from left of A to right of A, left of B, right of B. I have C. From here to here, it will be a straight line. It's a linear line. So I'll join these 2 points. Next I'll join left of D to right of D, and last I'll join 2 to 0. So I'll just trace this point. This is positive shear force, this is negative shear force, and this is positive shear force. And now I'll draw the hatching line. Here I'll just write this is 1 degree and 1 degree in case the line becomes curved for any drawing error. Next I'll calculate the bending moment values. To the left of section, I see any moment going clockwise. I'll say it is positive bending moment. I'll start with point A. At every point, the value will be calculated once because there is no moment on the beam. When I stand at A and I look to the left, there is no moment. So I have 0. Bending moment at B. When I stand at B and I look to the left, VA turns clockwise. So it is 4.5 into 1, which is 4.5 kilonewton meter. Next, when I stand at C, VA turns clockwise and 5 kilonewton turns anti-clockwise. So I have bending moment at C as 4.5 into 2 minus 5 into 1. I get the value as 4 kilonewton meter. Next, I'll calculate the bending moment at point D. When I stand at D, I have VA turning clockwise, 5 and 4 turning anti-clockwise towards D. So I have 4.5 into 4 minus 5 into 3 and minus 4 into 1. I get the value as minus 2 kilonewton meter. This is minus 1. Next, I'll calculate bending moment at point E. I'll have 4.5 into 5 minus 5 into 4 minus 4 into 2, and I have this VD turning clockwise. So I have plus 6.5 into 1, and I have minus 2 into 0.5, which is this value. I get this answer as 0. So I start at 0, I end at 0, my values are correct. I'll plot them. This is my point A, this is point B, C, D and E. At point A, the value is 0, so you can just write down here 0. At point B, the value is 4.5. At C, the value is 4. At D, the value is minus 1. And at E, the value is 0. Now, there is no UDL between A to C, so I will join with straight lines. 0 to 4.5. And 4.5 to 4. Next, between C to E, there is a UDL. So if you imagine that there is a straight line like this over here, so I have to draw above the line. So my curve, okay, I'll just draw the imaginary line for you. Say this is my imaginary line. You can see my imaginary line here. So I will be drawing above this line something like this. And here also I'll draw above the line. So this is a 2-degree curve. This is to be joined. This is negative. And here it is positive bending moment. I'll draw the hatching line. I'll just write this is 1 degree and this is 1 degree. Now if you observe here, there is one point over here of contraflexure. Let me call it as F. I need to calculate this distance x. So for this I am going to draw this much portion from A to F. Now you can either draw A to F or you can draw F to E. That's your choice. I am drawing A to F. So I'll have A where there is a load VA, where there is a reaction VA 4.5 kilonewton. Next I have point B at which there is a load of 5 kilonewton. Next I have point C, and finally up to the point F. So C to F I'll draw a UDL of 2 kilonewton per meter. This distance is 1 meter. This distance is also 1 meter. And the C to F is something I do not know. So let me mark this distance as X and let me mark this distance as X1, because this is the distance which I need to know. Now I'll draw the FBD of this. So at A there is 4.5 kilonewton. At B there is a load of 5 kilonewton. Okay, now between C to F, this load will become 2x and the distance will be x by 2. This is point F. So C, this is 1 meter and this is 1 meter. Since F is the point of contraflexure, I can say that bending moment at F is 0. Now suppose if I turn all the forces towards F, I'll get 4.5 into 2 plus x. Next I have minus 5 into 1 plus x, and this will be minus 2x into x by 2 is equal to 0. When I solve this equation, I get the value of x as 2.372 meter. Now since this distance, this is x, is 2.372 meters, so the distance of A to F, now this is 2, so I'll have 2 plus 2.372, which will be 4.372 meter. So this is how the numerical is supposed to be solved. I hope you have understood the numerical. If you have any doubts or if you want me to solve any question, please write to me in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. See you in the next session. Thank you.